Hi everyone and welcome to Dissection 3. Today we want to dissect a can opener. So as you can see, I have a can here, can of soup here. And how this one works is that when I place this here, there's a magnet that kind of attaches to the can. And then there's a knife here. Let me show the knife to you. There's a knife here. So you first attach the can to this magnet, then you place the knife on top of this so that the knife can enter the can. And then when you turn on the can opener, this gear rotates so that it can rotate the whole can, and then the knife can kind of open all the metal. But since I don't need this can, I'm not going to open it right now. So let's see. This is inside the can opener. So the model that I have here is Black & Decker. It's a little bit different from what you have in your EASM file, but the whole concept is the same. So this whole thing is the motor. And then this motor, when it's connected to the electricity, it kind of produces a rotational energy. And this rotational motion is kind of starts from here, this motor shaft. There is a gear that is attached to this motor shaft, and then this motor shaft kind of transfers the rotational motion to this gear. So when this one rotates, this gear rotates as well. By the rotation of this gear, another gear which is here, I'm just trying for you to see. Yeah, another gear which is here will rotate, which in the end rotates the bigger gear. And then this bigger gear is finally connected to the gear in here, which as you can remember, it rotates the can and can open the whole can at the end. So for this tutorial, we are asking you to model the whole gear train. So I mean all the gears from input to the output. So input is here, and then this one is as I said, there is a gear on top of this motor shaft, which you can see it in your EASM file. Then this gear is attached to this one. Then there's a smaller gear here, which kind of runs the bigger gear. And then this one which was attached to here. But we're not asking you to model here this one. So we're asking you to measure all the gear train, and you have to include all the supporting shafts and attachment methods as well. And you can place all of them on a simple substrate. Okay, so we don't need you to model the motor or model the casing. No, we don't need all these things from you. You have to model these gears using the toolkit. So in order to do that, you need the gear parameters, like the pitch diameter, the number of teeth, or everything. And I'm sure that you can have all of those information from the EASM file. So for the second task, we are asking you to modify the current design. Imagine that the current task is given to you. Consumers have complained that the original low-cost design jams too easily and thus cannot open some cans. Fix this problem by increasing the torque output of the gear train by 25% to 50%. The new design should be able to fit within the same space. So let's do. And then connect to the input and output at roughly the same locations. Input and output, it should fit here. It should connect to the roughly the same locations, and it should fit within this casing. So considering all these assumptions, you have to redesign the gear train in any way that you see it fits. Okay, and So you may choose to prioritize either cost or quality or a balance of two, and you have to kind of justify all your choices. So you can either, for example, change the number of these gears, or maybe you can, I don't know, add another gear. So again, you have to think about both cost and quality, and you have to design all your new gears, and then you can use the some parts that you used from the original design. You are free to do that, and then you have to kind of put them together with an increased torque from 25% to 50%, and all these gears should work properly. I mean, you have to mate them properly so that they can move properly. Okay, and let's see what else do we have. So, and then you have to, so for this assignment, then you have two assemblies. One is the original can opener, this one that you're seeing right now. The other one is your modified one with those assumptions that you have in mind. And then you have to export the drawings as well. Like the previous assignments, we have 4 questions for you to answer. So for question 3, it asks you identify the materials that are used in this original design. So for here, you see that everything is plastic, all the gears. But in the EASM file that was given to you, some gears were not plastic, they were made of another material, so you can find out very easily. And I guess for the last question, we had that identify the shaft attachment methods and gear shaft support elements used in the original design, and what methods would you use in your new design and why, which I can guess that I'd say that you can easily guess what shaft attachment methods were used. And yeah, that's it.